Good morning to all. Welcome to the day 9 lecture 1. So from yesterday we have already started the blockchain applications in different sectors. E-governance is also one of the sector where blockchain can better help to address the various challenges. So in this lecture we'll see that different case studies of the e-governance, and we'll see that what are the challenges in this particular domain, and then we'll see the different applications. So one of the application is the digital artifact management. Then we'll see that one of the, I can say, proof of existence, that when these particular digital artifacts were created, who has issued, and it ultimately it is proving the ownership of the particular digital artifacts. Then we'll see the one of the case study, remote voting. You know that voting process is too complex, but it is simplified over the years. Blockchain can better help to simplify voting system, and it will reach to the all the regions. So anyone by sitting at home can also give a vote. But at same time, there are various requirements which need to be fulfilled by the system. One another use case which is not mentioned here, that is e-KYC. So KYC process, although it is simplified, but you need to produce your KYC document to each organization. For example, if you have the account at various organizations, every organization will ask you every year to update your KYC. You have to go there, or you have to online submit your documents. Your documents are being verified. That means it is, I can say, consuming your time, because same process you have to do at various different organizations. At same time, the manpower which is hired for verifying your document, that is also like for same verification work is happening at different organizations. So how we can simplify e-KYC process, and here blockchain can help. So these three case studies will be covered in this lecture. So now governance system you can understand that there are various government and public sectors where you need to get the documents, different documents. Let's say one example is digital locker. That is also one of the kind of e-governance application where all the different ministry related documents. Take the example of driving license, which you can store at that DigiLocker, and it is trusted platform. So if you are downloading any document through such platform, and if you are showing to someone for verification, it will be trusted document. So this is related to the like digital identity management, where all your documents, let's say driving license, PAN card, whatever government issued documents are there, which can be stored over digital locker. So in India, various initiatives have been already taken towards the e-governance. So few of the examples I mention here: DigiLocker, My Government, Mobile Seva, Umang, Darpan, even Beam UPI. This is like full digitalization, where it is kind of like success story of the digitalization, where you need not to carry the money. You have to take this wallet in your mobile, and you can perform a small or micro transactions also. Okay, and all of you are aware that how you are using the UPI. Fine. So these are the, like I can say, e-governance applications. Now blockchain in e-governance, how blockchain can help in this such e-governance? First of all, it will enhance the transparency. Transparency in the sense you are submitting you are collecting document, whether document should be visible to the every authority that who has issued, at what time, and whether it is valid or not. So verification should also be there. And if such documents are available on blockchain platform, it will be very difficult to tamper such documents. Otherwise, you can see that there may be some fake documents. Passport is created, but photo may be different. Okay, Aadhaar card is created. People can use the copy of the Aadhaar card and can produce. But if such documents are being verified over the blockchain, it will offer the security. Efficiency of the government operations. I'll take the one example. If you earlier days, if you want to get the PAN card or Aadhaar card, you have to go to that particular place. You have to submit all your data. Then it was like paper-based work. Now, through online portals, you are able to submit all the documents. But after that also, you have to submit, post all your documents to the office, where it is going through the different offices, and your documents are being verified, and after that government will issue the document to you. Fine. Means, why we cannot include all this process over the blockchain, and we can take the help of the smart contracts. So let's say, I'll take the simple example of educational system, where your degree certificate is being generated. So the person, or I can say the staff people, will print all your degree certificate. Signing they cannot do. Signing is done by the authority. After signature, that document will be given to you. This is the process where multiple people are involved. It is better to generate the digital certificate, and only by giving single consent to all document, authority can sign all the documents on such platform. Fine. So it is simplifying the process. It will speed up the process. Nowadays, you know that compared to the earlier days, it is easy to get all the government issued cards. Maybe birth certificate, maybe the death certificate, driving license. Now it is very easy to get the driving license. Easy in the sense, not in terms of that you need not to give the test. But when you are giving test, within 1 or 2 days, you can get your license through online. You can apply online. So digitalization is helping a lot in e-governance because it is speeding up the process. And at same time, blockchain will offer the security, transparency, and privacy. Fine. Now coming to the digital artifacts management. First of all, we'll see that digital artifacts, any digital content, maybe audio, maybe video, your research papers, then your presentation, any document which is in the form of digital, that is called as a digital artifacts. Now, if I'll consider, I have produced one short video that I have uploaded on social media, and I'm getting lot of likes, suppose. But whether I am the owner of that video, how I can prove the ownership of that video? I might have taken from somewhere else, and then I have uploaded. Because this is creating the new revenue system. Earlier days, it was very difficult to prove the ownership of particular contents which you have created. Let's say one manuscript you have written on paper. Spreading that manuscript at global level was difficult when digitalization was not there. Now coming to after the digitalization also, suppose if I am writing some content or some code, or take the example of some patented work, that is my design of any product. How I can prove the ownership of that patent? Because there is no search database is there. It is checking based on the keywords. But whatever I am proposing, whether it is duplicate or not, whether the genuine owner is available or not. So blockchain can help here. Whatever designs, whatever codes, whatever videos, audio files, images or photographs which you are creating, that is your asset, or can be called as a digital asset, which can be uploaded over the blockchain. So it is kind of like non-fungible token. So I will cover what is the non-fungible token and fungible tokens. Fungible tokens are the like cryptocurrency, which can be easily transferred and which has value which is varying over the period of time. But coming to the non-fungible token, where your digital assets are there, those digital assets will have the value which you have defined. So non-fungible tokens can be traded. You can sell. I'm not talking about transfer. You have to transfer the ownership. But in case of cryptocurrency, suppose if you are holding some cryptocurrency, initially you will be owner. Once you are transferring, it is just being transferred to the somebody else's account. There is no ownership concept. Fine. If I'll take the example of I'm having 100 rupees note. I'm going to market, I'm purchasing some item. I'm giving 100 rupees and that person is giving me what? Some change according to the value of that particular product. Thing is that no one is the owner of that 100 rupees note. At same time, during inauguration we have seen there is one photo frame on which signature was there from Mario Gallery. Mario Gallery is having that mark because that is called as their own artifact. I'm not talking about digital artifact. Photo frame is the artifact. No one can claim that this artifact is created by other than the Mario Gallery because of signing is there. Fine. But that artifact can be given to somebody based on payment or based on the gift. So it can be traded. It can be given. So here ownership. Who will be the owner of that particular picture? Mario Gallery only. Only it is just sold. Fine. So coming to the non-fungible tokens, it cannot be transferred. It can be sold. So this is the difference between the fungible tokens and non-fungible tokens. Got it? Yeah. Challenges. Authenticity and provenance. If I'll consider the cultural heritage, like let's say at particular site some photos were taken. Now that heritage site information that during what time this site was created, if this information is not available, tomorrow someone else will come. They will also do some other things there. I'm not giving particular example. I'm saying that if it is changed, then that site will be belonging to that particular culture. This is what we have seen the history of the India. Okay. So always changes will happen on every site, cultural site. Question will come, how you can authenticate that this site was belonging to whom? Fine. It is difficult to prove. But if such information based on the timestamp is available on the blockchain, and as you know that blockchain is immutable, it will store all such records. Later, it will be very easy to prove that this site is belonging to whom. Fine. Coming to the transparency. As all such data, I'm talking about not data, actual data, I'm talking about information. Information related to such site example, then such codes or videos, audio files, images or photographs. Fine. If such information is available on the blockchain, it will give the full transparency. So those who would like to copy, they need to take permission. I'll take the one example of Bitcoin. Bitcoin blockchain, now if you see that everyone is claiming that I am the owner of the Bitcoin because it has generated the value. But it was developed by the what? Anonymous author, Satoshi Nakamoto. Think. Now today you are writing one code which you are publishing on GitHub, which may be like I can say advancement of any other cryptocurrency with I can say additional security features, additional contracts that you are publishing. That is your code which you have written, and generally people are uploading their code on the GitHub. Fine. If any business is identifying this code can or realize, any business can realize, suppose this code can generate more revenue than the other cryptocurrencies. Person can copy code and can start the business. Then later for you it will be very difficult to claim whether this code is belonging to you or not. If such codes are recorded on blockchain, it will be very easy to claim. And authorities can easily prove that this code is belonging to you. Fine. So that code can be traded, but if you are not using the blockchain, if you are not using the secure system, anyone can utilize your code. That means such NFTs are generating new revenue system. By sitting at a home, you can create digital contents by considering the other requirements. Requirement cannot be only like I can say technical requirement. I am talking about the I am creating good pictures. I am going to the, let's say, some sites. I am clicking very good pictures. This picture is clicked by you. Okay. Now, if that picture is having value, that is called as a digital artifact, and which will help you to bring new revenue system. If you see that there are a lot of art galleries in every city. The art gallery may be like painter is painting, based on that, paint or person is clicking the images, those images may be unique images, which is not available. So NFTs are representing the uniqueness in your artifacts. Coming to the efficiency, it will be very easy to verify and prove your records on blockchain. Deepfake prevention. You know that currently there are many incidents happening about the deepfake. Suppose you are creating some video, audio, or I can say images. Person can apply AI/ML tool and modify those contents. Then it will be difficult to prove that what is the original source of this particular image, video, or audio. I am not talking about detecting, I am talking about preventing. If person is copying that artifact is already recorded on blockchain. If person is copying, and if you are knowing that this is related to my content, then it will be very easy to prove, because on blockchain nobody will be able to modify that record. So blockchain can help here to solve all such problems in the digital artifacts management. So CDEC has developed the proof of existence. Proof of existence is showing that this particular content is existed from which date. It is not proving the ownership, but it is already existing in this world. That is what the proof of existence. Try to understand the difference between ownership and existence. Let's say wheelchair design. I am talking about one example, wheelchair design. If that design is already exist, and if it is recorded on blockchain, and suddenly you are coming to know that similar or same design is coming in the market, you can easily verify this particular design is exist from which date. That is what the proof of existence. Okay. So CDA can develop the permission blockchain based platform for the proof of existence of the document, which is offered as a service. So it will help to prove that certain digital artifacts with specific content are already existed on a particular date and time. On a particular date and time. Suppose today in a quiz, I am saying that all of you solve some complex problem for which solution is not there. Now, if any two of you are solving that problem, and that problem solving is really helping to the real world application, question will come, that solution is exist from which date? So once you are solving problem, immediately store your data on the blockchain. On blockchain, you can store date and time when you have solved that problem. So if anyone else is solving problem, will not be able to claim that that person has solved, will not be able to claim that I am the first to solve that problem. Because that existence is there. Solution is already existed on the blockchain. So it generates the cryptography. So how it is happening? Suppose let's say you are applying for any of the document in government. So government issuer will issue the document to you. Okay. That document should be recorded on the blockchain along with the timestamp at which time and date this document is issued to you. If this data or information is available on blockchain for a verifier, it will be very easy to verify that document. If I'll take the example of that all of you submit 10th class marks certificate to me. Okay, so all of you will come up with that copy or a copy of your 10th class mark certificate. On that date and year is mentioned. Fine. But it can be updated. For me it will be very difficult to, because if you are using same design, for me it will be very difficult to verify whether this document is existed from that date or any other date. Similarly, birth certificate. If all of you will submit birth certificate to me, for me it is difficult to trust on that copy. But the issuer of the birth certificate is uploading such document on the blockchain, and that data cannot be tampered on the blockchain. For me, it will be very easy to verify those documents. So, in this proof of existence, how data is being stored? All your digital artifacts will be stored in some secure storage, and the S of that S of that document will be uploaded on blockchain along with the timestamp. So the transaction on blockchain will be what? S of that document as well as the timestamp. Question will come, why only S of the document is stored? Due to the privacy concern. Due to the privacy concern. I do not want to disclose my data. But to prove the document, I can give the information. So information is the S of the document. Try to understand the difference between the actual data and the information. Actual data is your digital artifact. And information is what? I can say attribute of that particular data, which will not affect to the privacy of your digital artifacts. That means it is providing the anonymity. But document can be verified through that S value. Then permission verification, privacy of data. But most important part is that getting a decentralized proof, which is very difficult to tamper, because that document is uploaded on blockchain by taking the confirmation from the multiple users. So if at one of the database, if that document is being tampered, but that tampered document will not match with the other database, because that record is S of that document is being stored at what? Every node. So no one can tamper it. So ultimately, you can manage all your digital artifacts on blockchain, which will enhance the security of your documents, codes, or any digital contents which you are generating. On social media, you might be seeing I can say those who are using social media, let's say Instagram, or they are creating their own reels and they are becoming famous. Question will come whether this reel is generated by you, that is showing ownership. But whether this reel is belonging to you or at what time it was generated. Suppose let's say you are composing new music which is trending now. Question will come whether this music is existed from which date and whether it was belonging to you or not. So composing new music is also called as one of the kind of non-fungible token. Fine. So this is the diagram of the proof of existence developed by the CDEC, where all your digital documents or artifacts will be recorded in the form of S value on the blockchain, and you will be assigned as a receipt. Receipt will be what? S of that value. Now suppose somebody would like to verify whether that is belonging to you, me or not. I can show that receipt. It is kind of like digital certification on your digital artifacts. And that record is on the blockchain. Now verifier will provide what? S and transaction ID from the receipt. What a receipt is issued to you, by using that receipt, verifier will use that S of that document and transaction ID from that receipt and will go for the verifying the document's proof of existence on blockchain. If such record is available on blockchain, that means proof of that existence of that digital artifact is proven. If it is not exist, it is not available on the blockchain. Fine. So it is offering the security because it is maintaining the data integrity, authenticity of the digital artifacts, epoch of the vital data, seamless authentication, avoiding the physical submission of the document. You need not to submit any document in physical mode. So it will reduce the paper-based documentation. It will record and maintain the S of the digital artifacts in tamper-proof manner. Issuing receipt, that receipt includes the S of that particular digital artifact and can be embedded QR code in this particular service. But if you are developing your own application, it is not mandatory to embed the QR code. You can provide any form through which verifier can verify that S value. Whether that S value is exist on blockchain. So remembering that 256-bit S value is very difficult. You can create the new key, let's say QR code, by using that S code. Scan that QR code and verify whether that S code is available on blockchain or not. If it is available, means what? That digital artifacts is already exist. I'll tell another example. During placement season, the employer will verify your documents. You are submitting all your documents in the digital form or the physical form. But how employer will trust on those documents? Because that is submitted by you only. It can be tampered also. So all the employers are sending those documents to the particular institutes which has issued those documents. And their service fee is involved, because for institute it is creating what? Another work. And once institute saying that we have issued this document, then and then only employer will satisfy with those documents. So here what is happening? First time, students are submitting or uploading documents to the employer. This is like one process of uploading document. Employer is sending the document to the issuer, that is the institute or organization, where verification. So it is time consuming process. Also, service fees are involved in this case. Your employers are not directly sending this. They are also hiring some third party service for verification of such documents. Okay. So with this blockchain and proof of existence, you can avoid this complex process. It is so the service is providing dashboard for indicating match or mismatch after verifying the blockchain details. It is malware resistance also, this particular service. It is improving the availability and integrity of data, where the data is being recorded at some secure storage, but hash of the value is stored at the what? At each and every node. So availability of data is maintained. So instead of storing at particular single location, it can be stored to in a distributed manner. It is more scalable. Why it is more scalable? You are not going to verify all the document content. You are just verifying the hash value. So verifying hash value will be faster than the what? Verifying in this sense, you are not recalculating the hash value. You are checking whether this hash value exists on blockchain or not. So it is just matching the hash value. So that will be faster than the what? Verifying the contents. And that is why it is more scalable. It is providing the improved security as well as monitoring, and having the ability to prove the existence of the document on particular date and time without revealing its content. It is not revealing the content of your digital artifacts. It is just proving the existence of that particular digital artifact. So blockchain can better help for the digital artifact management. One of the case study, because whatever journal papers you are writing, or whatever conference papers you are writing, that is also one of the kind of digital artifact. Whatever patents you are writing, or whatever designs you are creating, that is also digital artifact. Now the question will come, whether this design is exist from which date? From which date this particular design is exist? If all the sources where you are submitting all your designs are connected to the blockchain, so all the designs can be on blockchain, it will be very easy to verify the existence of that particular design. So the Journal of British Blockchain Association joined with the artifacts portal. The journal is accepting the submission of the journal papers, and now this portal is integrated with the artifacts portal to upload all our journal records. Otherwise you are seeing that even though copyright statement is there, but still people are copying what? Images of the journal papers or conference papers, and many times permission is not being taken. Even if permission is being taken, denial can be taken place that you did not take permission. Okay, to avoid all such problems, if such consents are recorded on blockchain, that I am utilizing your design for non-commercial purpose, kindly permit. So you will give me the consent, okay, you can utilize it for non-commercial purpose. So I can write the smart contract along with some consent management, and that consent should be recorded on blockchain. Later you will not be able to deny that you did not give me permission, and I will be able to prove that after taking your permission I utilize your digital contents, and all this information can be recorded on blockchain. Similarly, so this is artifacts are built on the Bloxburg ledger, which is the global leading science focused Ethereum blockchain based infrastructure managed by the international consortium of the prominent research organization. So all the research organization can join their hands and can start utilizing the blockchain to upload all your journal papers, conference papers. So this is led by the Max Planck Society's digital library. It utilizes the blockchain and Web3 technology to create the searchable and citable index metadata of the pre-published and published work. So you can access the metadata of that particular papers. But if you would like to really see that content of those papers, you need to take the consent from the particular owner or from the particular society who is publishing such contents. Fine. So this is another opportunity or challenge, how to create the consent management platform. One side we are providing the proof of existence. At another side, we need to create one setup or we need to build one setup on the top of blockchain to provide the secure consent. And that consent should be always available. Available in the sense, suppose I am contacting you via email that I want to utilize your content. You are not available. Then I will have to wait. That should be automated consent management platform. So in cryptography, you might have seen the re-encryption scheme, proxy re-encryption scheme. On your behalf, proxy can give the consent based on your configuration. So I'm not going into the detail of those cryptographic techniques, but I'm saying that consent management platform is required here. It is receiving the citations in real time and enhancing the recognition. So whatever journal papers are there, its citations are being recorded. So it is giving what? Worldwide recognition to your digital artifact. It records the smart contract proof of existence, offering the access control. It is synchronized with the ORCID database. I hope all of you know the ORCID database. That database is linked with the all your digital identifiers, digital object identifiers. So whatever papers we are publishing, journal papers or conference papers, for every paper there will be unique digital object identifiers. Based on those identifiers, ORCID is maintaining the database that which papers are belonging to you. Fine. Now, if such portal is linked to the ORCID database, you can provide the proof of existence that this paper is belonging to you and this paper exists since this particular date. Synchronize with the institutional repositories. You register the material, immediately cite via the Google Docs, and you can track the progress via the dashboard. So this is one of the case study where blockchain is used for the digital artifacts. So as I mentioned, if you see here, your research data is there. From the research data, hash of that particular data is created. That hash is going to be stored on blockchain along with the timestamp. Along with the timestamp that on which time or on which date this particular digital artifact is stored on the blockchain. And this is proving the existence of this document. It is not cryptocurrency. We have seen in cryptocurrency that it is showing the transaction, it is storing the transaction value, which can be easily transferred from one wallet to the another. This is not being transferred. It is proving the existence of that particular data. Yes. Another application is the e-voting. Now, what are the requirements of the voting first of all? Main requirement is each valid voter should be able to vote in the given time duration. All the Election Commission of India has already taken care that they have created the cluster based on the polling booth that how many voters will come and whether they will be able to vote in given time or not. So that time management is already taken care. But when you are going on the digital platform, each valid voter should be able to vote. Equality, accessibility, it should have the openness, means access to the all. And everyone should be able to verify whether your vote is being recorded or not. So here it is like contradicting requirement. You should be able to verify your vote, whether your vote is being recorded or not. But during counting time, counting person should not be able to see that where you are given vote to whom. They should be able to count only that number of votes are given to which member. So here privacy requirement is also there. Interoperability. Such platforms should always work on different platforms. Suppose if you are using different browsers, it should not be dependent on particular browser or particular software. Fine. So what are the security requirements here? What voter authenticity? System should be able to authenticate the voter, that valid voters should be able to vote. So you will have, obviously you will require the credentials, username, password. There are many methods available in cryptography to authenticate a person. But how system will ensure that you are not given your credential to somebody else? This is also another requirement. On your behalf, nobody else should be able to do voting. That is very easy to verify in the physical mode. But in digital mode, by sitting at home, if you are remotely voting, how to verify that you are not given your credentials to somebody else? This is a challenging requirement. Uniqueness. You should be able to vote once only. You should not allow to vote multiple votes, I can say. So there should be some serial number which should be bound with your identity. Eligibility. So eligibility checking is also required. Anonymity. You are giving vote, nobody else should be able to see that to whom you are giving vote. So that anonymization is also required. Secrecy of the vote. Before the announcement of the result should not come out. All the voting information should be kept secret. Data protection. What your data is there, it should be protected. So here one side we are talking about the full transparency. At another side we require all these security features. So this is like contradictory challenge, but both need to be fulfilled. And that is why voting system, digital voting or e-voting can be called as some complex system, which required to be fulfilled, which should be thoroughly analyzed. Because if single error will happen, then whole process will be failed. Reliability of the system, testing of the votes, whether these votes are genuinely submitted or not. So later verification should take place. Testing you should be able to do testing of those whole process. Monitoring fairness in a voting, and availability. System should be available, and whatever votes are recorded, that should also be available. Today you have voted and someone has performed attack on that database and all the votes are deleted. That should not happen. Or you are voting but that vote is not being recorded. You are just getting message that your vote is submitted, but backend side your vote is not being recorded. And there are many reasons that why your vote will not be recorded. Maybe due to the attack, maybe due to the connection failure. So different reasons are there. So in past, it was ballot-based voting. As all of you are aware that before EVM-based voting, in past, Here ballots were being issued and voters were going to the secure compartments and were putting the stamp, and that ballot they were putting in a one box, and that box will be being opened during the result announcement date. And at that time, lot of issues were also faced. One is that lot of paperwork. Second thing is that you need to issue the wallet, you need to issue the ballot. If there is a big queue for everyone, you need to issue the ballot. Person is going in a compartment, not coming out on time. Or person is putting a stamp. Person is putting a stamp. That stamp is going out of box, or it is not properly done. Although lot of awareness programs were run, but still lot of issues were there. Third thing is that securing this ballot box, because where all the votes are being submitted, securing that box. Again, verification, whether any malpractice has happened or not, because here you will not have your own identifier. In this, whatever vote you have casted on vote, you will not have your own identifier. So verification and testing was also difficult. So after that, currently EVM based voting is happening, where it is made of 3 units: control unit, VVPAT unit and ballot unit. Control unit is in the end of the what? Polling officers who are at the polling booth. There is an observer who is observing whole process and presiding officer. Fine. This VVPAT and ballot unit are kept in some secure room that nobody will be able to see that to whom you are giving vote. So votes are being casted using these 2 devices, VVPAT and this EVM. Fine. This is also one of the kind of, I can say, this is voting in India, but it is not electronic vote. It is not like remote voting. Fine. This is working fine, I can say. Now coming to the e-voting. If I want to run same process, if you see that there is no internet connection here. The whole process, all devices are working on the battery operated devices. These are battery operated devices. So no internet. So there is no chance of attacking on recorded wallets, recorded votes. But coming to the e-voting, there may be high chance of attack because it will be connected through the internet. So this is the one of the, I can say, e-voting example which is found in one of the research paper, that how you can deploy such service on the blockchain. So first of all, voter registration should take place. Voter image will be captured, because during voting time, you should be only allowed to do vote. Your credentials should not be taken by somebody, or your credentials should not be transferred to somebody to cast a vote. So your facial image is required during voting time, and it should be verified at same time. So that is why voter's image should be captured. Voter's QR code will be generated, that is kind of like ballot, which will allow to vote. And using the API calls, you will be able to see the candidate list. And through this smart contract, you will be able to cast a vote, and that will be recorded as a blockchain transaction. Once it will be recorded as a blockchain transaction, no one will be able to tamper your vote. And as it is providing the transparency, without revealing your identity, you will be able to verify your vote, whether your vote is being recorded or not. Fine. You will be able to see that to whom you have, but that here again access control is required. You will be able to see only your vote. You should not be able to see that others vote, that to whom it is given. Because blockchain transactions will be sequential. Before you, somebody is giving vote, and you know that before me someone has given vote. But as it is remote system, that part is also prevented, because at a time multiple users are submitting vote. Fine. So it will provide the immutability of your casted vote. and on result panel you will be able to see the result. It is highly scalable, but it is more prone to the network attacks. Maybe on the election day, system is not exhausted due to the flooding attack. There are various attacks which we have seen in the network security. Those attacks can be possible here. So before deploying, because this is kind of like application which is affecting at the, if it is affected by the security, if it is affected by the attacks, its impact will be very high. So before bringing such application in the real time, it should be thoroughly tested against various security attacks, because it is internet based. This is another example which I found in one another paper, where they have also shown the how blockchain can be helpful for e-voting. So first of all, election creation will happen, that who are the candidates, candidate list, voting districts. So this is like ballot contract. So you can write all these details on the contract. So once you are registering for, once you are initiating your vote, initiating your vote casting, contract will verify your identity. But that should be private component. Because next time, in next step, your vote is being recorded. So someone should not see that contract is verifying which identity. And we already see in one lecture that smart contract itself is having the various vulnerabilities. Those vulnerabilities should be also patched. So it should be, all the contracts should be carefully written. And there is a proof of authority network. Now proof of authority consensus is already covered in this course. Only authorized people should be able to confirm those transactions. Now question is how to give authority. But those who are counting, they should not be like verifying. They should not be verifying nodes. Verifying nodes and counting nodes should be separate or isolated. Where verifying nodes are verifying what? Users. Counting nodes are verifying what? Or counting the votes. If they will collude, all the personal information regarding your information will be linked to your vote. Privacy will get affected. So yes, so here it is mentioned that blockchain can better help to solve problems in the e-voting, but at same time proper security should be taken care. Yeah, before stopping this lecture, I would like to cover the one of the another use case, eKYC. So in eKYC, already you know that at every organization, let's say I am talking about the bank, you are having account in different banks. Okay, every year you have to submit your document, you have to update your KYC document. Fine. Thing is that this process is that suppose you have account in bank 1, bank 2, bank 3. As a user or account, you have to submit documents either physically or remotely to this bank. Process is same, because already for KYC list of documents are mentioned. It can be your Aadhaar card, it can be your election card, it can be your driving license. So list of documents are given which can be, I can say, valid for the KYC process. Now suppose if you are physically going to each bank, their manpower is deployed. So manpower cost. Manpower cost is also involved here. Same process is happen 3 times. So it is time consuming process. Fine. Now the question will come, if I am submitting my KYC document to the one bank, and one bank is verifying me by getting document, why this bank, why this status that bank 1 has verified my record, one can give the consent to the second bank saying that I already verified the documents of this user. Are you getting? Your time will be saved. Verifying same document and again can be avoided. So it will save the cost and time. But challenging part here is privacy. What is the challenging part is that no bank should know that in which are the other organizations I am having account. This is my own privacy. Are you getting? This is my own privacy. Without my consent, one organization should not tell that I am having account in this organization. Fine. Again, coming to the bank side. Any bank will not be willing to reveal their customer information to the another organization. Fine. Now, to solve this problem, you can take the advantage of the blockchain. So, suppose, let's say, at center I am keeping the blockchain. Fine. At center I am keeping blockchain. At this side, all the users are there who are having account in various organizations. So, this side I am taking the organization 1, organization 2, organization 3. First time when I am performing KYC, I will submit my all documents to the organization 1. But that document will not be submitted to the organization 1. I will store my documents into the secure database, okay, where I will have the KYC documents. We have already seen the document chain. The documents hash value should be stored on the blockchain. Fine. Now this organization 1, the hash value, these documents are stored by the issuer, and that hash is generated, that hash is being stored. But I do not want to give the access of those hash value, so this should be the encrypted value. Fine. Now suppose bank 2 is asking me to come for the KYC verification. I need not to do the same process again. I will give the consent to the bank 2, that it is already verified by the one of the organization without revealing the organization 1's identity. Fine. Now the question will come, how service cost will be set? So this will be like, already as organization 1 has verified, so organization 2 will believe on this. To generate that belief, we require the blockchain. To create that trust that organization 1 has already verified my KYC document, to create that trust, we can use the blockchain. And that consent is provided by the users. Coming to the organization 3. Fine. Coming to the organization 3. When organization 3 is coming, as it is already verified by the other 2 organizations, it will be verified based on the hash value. No need to submit documents again and again. Fine. Documents will be available at secure storage. Let's say digital locker, where all your documents are issued. But the main question is service cost. Suppose overall KYC verification process cost is the N. So this cost will be paid by the organization 1. Now organization 2 will be there. Now organization 2 should pay N by 2. Just for example, I am saying that incentivized mechanism, just for example. Organization 2 will pay the N by 2 to the organization 1. So n by 2 recovery happened. Now what is the cost on both the organization? N by 2 only. Okay. Now third organization is coming. This third organization should pay how much to this? N by, let's say 3. N by 3. This will become what? 2/3 of the n. That cost will be on the organization 3. And once this will grow, organization 1 will have the less cost because it is being recovered. But as organization 1 has invested, it has to wait for the time. But who will be benefited at the end more? In this case, who will be benefited? Organization 1. Well, n by 2 is already covered by the from the organization 2, and then n by 3 is paid by the organization 3 to the 1. So now how much cost is covered by the organization 1? N by 2 plus n by 3. This organization n by 3 only. For this organization, nothing is recovered. But how much paid? 2n by 3. Fine. This is just for example. You can think of any incentivized mechanism. So everyone will be willing to give that consent. And everyone will come first to verify. If I will be first, I will be more beneficial. Being an organization, if I am the first, I will be more beneficial. This is just for example. There is no case study available for this, no, at POC level. I am saying here the reason for this, eKYC can be simplified on the blockchain. What you need to take care? Privacy of the bank and privacy of the customers. Along with that, it should have the cost efficient model. By considering this, you can think of developing the eKYC application on the blockchain. So in this lecture we have seen how you can simplify the processes about the digital artifacts, voting and eKYC. And blockchain will be the suitable platform. Blockchain will be the suitable platform to develop such services. But at same time, blockchain related challenges are also there which need to be addressed before deploying such service. So those challenges will be related to the privacy, security, incentivization, and it can help for the, I can say, good digital e-governance. So e-governance applications, for e-governance applications, blockchain can better help. This is what I can conclude from this lecture. Thank you. If you have any question, you can ask me. As blockchain is maintained by the peer-to-peer nodes.
Hi, good morning. The next use case we are going to consider is that of the use of blockchain in storing and sharing healthcare data. So one thing immediately to notice about healthcare systems is that they're extremely diverse. Right, so installations at hospitals, collection of data through the registries, interactions between like different forms of patients. So there are so many different types of interactions within healthcare that actually it's quite so there are surveys that cover the use of blockchain in healthcare, but they usually concentrate on specific subcases rather than covering the entire field. So perhaps like what I'm going to present would not be as comprehensive so as to cover all of the area. Okay, so this specific illustration is for conducting medical research. So in medical research, there is an individual which may become a patient, but sometimes healthcare studies are performed on general populations, not necessarily on ill people. So individuals would interact with the healthcare service providers, which could be hospitals, clinics, and labs. And then those providers create healthcare data and collect it. And then by the regulations in many countries, hospitals and other health service providers are obliged by the law to transfer associated healthcare data to registries, and registers take care of the data, so fuse it, process it, and share it as need be. So, so for research entities demand access to healthcare data, or at least a part of it, for research purposes. So these are most of the interactions in the healthcare domain. Well, again, there might be some additional interactions. For example, patients or individuals self-organizing in support forums and so on. So the functional component of a healthcare storage system would be collection of the data, and collection is done through many different means, such as administrative forms at hospitals, lab tests, individual physicians, clinics, questionnaires sent to the patients or to the general population. Another functionality would be storage of the data. So the storage again would include many aspects, such as demographics. For example, could be are patients from a particular, or sort of, if you consider the entire population and you consider patients in a certain area, such as lung diseases. So it might be interesting to consider where there is high concentration of those patients in a particular area with particular genomic heritage and so on. And therefore, a lot of different questionnaires are being sent. So demographics, obviously diagnosis, procedures, and how the procedures, because the procedures are not the same, they're also developing over time, right? So there is a need to collect data about how successful procedures are and how the evolution of procedures affects the patients. Tests, prescriptions of medicine, obviously pharmaceutical, narrative notes from the doctors. Some of this data is collectively called electronic health record or electronic medical record. So there is a common abbreviation in this domain. But not all data covered by electronic healthcare records. For example, summaries submitted to the registries and demographics information is not part of the healthcare record. And of course, later the data needs to be shared and transferred. And sharing and transferring data is subject to a lot of different regulations in different areas. We are going to talk about the consent from the subject as one of the issues. So support for sharing of medical and healthcare data is vital. And indeed, there are many reasons for believing that. So first, there have been quite a few documented cases of medical errors because of inaccessible information. And in some cases, the patients died because of unavailable information. So for example, when a patient were brought to an emergency room without history of prior medical conditions and allergies, so allergies to medicine, so they were administered medicines to which they were allergic because of the lack of information. Just one example. It's also required for holistic healthcare and welfare because there are so many data sources. Today we have smart watches that can measure the pulse and the blood pressure and whatnot. So, and there is a need to collect all this data and sort of take care of the welfare of people. And this data integrated with the numerous data monitoring devices. It's also very important for traveling, for patients traveling between the states, between the countries, because if they need healthcare in a different place, there is a question of how the data is shared between the home place and the place of travel. And it's especially important for analytics, and where sharing is essentially the only way to develop new treatment methods and new medicines. On the other hand, healthcare is a target for frequency security attacks. So there have been so many publicized incidents of security breaches when it comes to healthcare data. So why is healthcare data so valuable? Well, for the very same reason. Pharmaceutical companies. Pharmaceutical companies is a big business, big pharma. So for them, healthcare data can be extremely valuable. And this is just one example. And the other example is that individuals can, like, private information about individuals can also be valuable. So in 2021, the statistics show that healthcare data breaches impacted 45 million people worldwide. And this is just the registered, the detected cases. Obviously, the real number would be even higher. So there is an inherent trade-off between the need to share the data and the need to protect shared data. On top of that all, the healthcare infrastructure, when it comes to storage, it's very conservative. Once developed, usually the hospitals and other healthcare institutions, they are very afraid to swap out the old infrastructure and bring a new one. And that, as a result, different places have developed different infrastructures, and we have isolated silos. So the different storage systems are not able to communicate with each other. So there is a need to introduce interoperability at many levels. Regulations, record formats, communication protocols, and so on. Now, to add to the challenges of storing healthcare and sharing healthcare data, it's important to mention that it's subject to scrutiny of ownership and privacy-related regulations. And there are many of those. It's one of the most regulated areas of data storage. Virtually every country has its own regulations. Probably the biggest one is pan-European regulations such as GDPR. Okay, so what do they regulate? They regulate what data can be stored where and shared with whom. So one small example. UK has the UK has its own regulations, according to which the data pertaining to healthcare patients in the UK cannot be brought out of the country. So could not be, say, shared with Google unless Google establishes an isolated data center in the UK. So not possible to do cloud analytics in general. And this is just one small tidbit, right, to explain how complicated. So every country, every regulation has its own rules. So there are many clauses governing the right of access to data. For example, GDPR defines 6 legal bases, six viable reasons for the right to access health data. And like for each access, the need for access needs to be classified. Okay, a bit more about GDPR. In GDPR, there is a need to record. So one of the 6 legal bases is previously given consent by the data owner or by the patient. Data owner would be the subject or the patients to whom the data pertain. So, so one of the reasons is previously recorded and documented consent decisions taken by the data owner, just one of the 6 bases. There is furthermore an obligation to report to the patient about all accesses to his or her data. So imagine like as a patient, I have the right to get information about every entity that got access to my data. At what point in time, for what reason, for which of the 6 bases, for how long, and so on. And finally, GDPR includes one provision which is especially challenging to achieve in the context of healthcare data, and that's the right to be forgotten. The right to be forgotten means that a patient can say, okay, like from now on I'm not a patient, I want all my data to be erased from the system. So it's a bit more complicated. There are cases when the patient may not have control, may not have the right to be forgotten, and there are other cases when the patient does. So in order to, in the context of one of the 6 legal bases, namely consent management, it requires really fine-grained consent management and access control schemes, and I'm going to get back to the question of consent management a few slides later. Okay, here you can see just some of the most prominent data protection laws and regulations in different regions. So in the EU there is GDPR, United Kingdom has its own DPA, United States has HIPAA, the main one, which is Health Insurance Portability and Accountability Act, but there are 2 additional ones, and like NIST, the National Institute of Standards and Technology, is also issuing some standardization in this domain on complementing HIPAA. And India has IT Act, about which you may actually know more than I do, but the point is that, again, every country has its own set of regulations. And those can be contradicting or conflicting with each other. So the same system which works in one region would not be allowed to operate in a different region. So let's get back to GDPR. GDPR defines 4 roles and responsibilities. Data controller, which collects and maintains subjects' personal data. Data subject, to which the data pertains, so individuals whose personal data maintain in the system. Data processor obtains personal data if authorized by the data controller and processes the data, performs some analytics for one or another purpose. And the supervisory authority is responsible for checking and enforcing the compliance with GDPR regulations for every entity involved. So supervisory authority would be auditing access log to check compliance with the, well, not only access log, actually all the agreements and all the information such as consent to check compliance with agreements. So data controller determines the purpose for which and the means by which personal data is processed and under which legal base. Data subject may decide on the consent for accessing personal data, and again, consent may be fine granular. It's not like I give access to all of my data, or I do not access to any of my data. Granular means that there is basically the data is broken into units, and there is separate consent management for each unit. Data processor means what does it do? It needs to comply with the defined access policies, providing safety, security, privacy guarantees when it processes the data. Okay, now, so this is like the background about data storage in the healthcare domain. Now, talking about the use of blockchain in this context. So blockchain-based healthcare system has blockchain and smart contracts have fundamental features which we already all know, like for the need for a trusted third party, data integrity, data transparency, and verifiability. And from those, there could be derived specific benefits for a blockchain-based healthcare system. So, for example, traceability and auditing. So patients will be able to trace and audit whether their healthcare data is managed as per the access preferences and policies they have defined. They should be able to audit their treatment and healthcare services state and outcome. And they should be able to trace their data and the history of the services they have received. And that information is available not only to the patients, but also to the auditing, to the auditors. Perhaps the very first case of blockchain-based storage system in healthcare was Medarec. It was a project which originally came from an MIT lab. It was around 2016. So in Medarec, essentially Medarec is based on Ethereum, and most of the system is based on smart contracts on top of Ethereum. So they have a miner, so which is later it was like one of the main points of criticism. So why for such a system do we need mining, right? And use of cryptocurrencies. So later system would be developed usually on top of Hyperledger and not on top of Ethereum. Okay, but in Medarec, for example, it was possible to in Medarec, the main part was the contracts. So there was one registrar contract through which a patient could register in the system. And the main element was the patient-provider relationship, which had to be managed on a contractual basis. And additionally, there was a summary contract for which allowed patients, but also other users, to search for the information. Another projects I would like to talk to you is a SmartMed project in which our institution was involved together with the Cancer Registry of Norway. So the project was about secure and accountable sharing of medical record using smart contracts and blockchain. So a couple of words about the Cancer Registry of Norway. The Cancer Registry of Norway is one of the oldest healthcare registries in the world. It has been storing data for millions of patients since 1953, which is again, like, if you put it in perspective, the whole population of Norway today is 5.5 million, but back in 1953 it was around 3 million, I believe. So the fact that they accumulated data for significant fraction of the population is actually quite interesting. And again, so they're collecting data from all healthcare providers in Norway, which by regulation are required to report data to the registry. Now, the objective of the project was to enhance security and tamper resistance of the medical storage at healthcare registry, to ensure verifiable and non-repudiable decisions by healthcare actors, to provide benchmarking of various blockchain technologies as possible platforms in this context. So, for example, the project tried both Fabric and Sawtooth, and they assessed different blockchain technologies for data sharing. And finally, to develop a verifiable consent management service for sharing medical data. So that was, and this is the part on which I'm going to focus. So the proposed architecture consisted of 3 layers: blockchain storage, the storage proper, or blockchain-based storage, distributed ledger technology, and the collection of smart contracts for health registries. So the smart contracts were to ensure security, to provide transparency and accountability, to configure compliance with regulations such as GDPR, and to provide additional degree of anonymization. So this is similar to what we saw previously. User interacts with the hospitals. So, but in this case, it was the cancer registry that was playing the main role of the healthcare registries, collecting data for all patients and general population. However, the Cancer Registry of Norway also were required to provide a verifiable consent management platform vis-a-vis individual patients. So the whole scheme maps to the GDPR in a straightforward way. Now, medical research project is broken into phases. So the first phase is the project proposal, in which the data processor must first formulate the study objective. Then this data controller needs to carefully evaluate the proposal, improve feasibility, and whether it is ethical. If approved, then the third phase would be a request for healthcare data, so data processor can execute the project and request the data from corresponding data controller. Finally, data subject should be able to change the consent policy they've already provided for their data usage. So there is policy update. There are some additional considerations, so it's actually like more complicated than this summary. For example, the data controller can provide the data in the form of sharing access to the database, can provide data in the form of transfer. It can decide to share the real data. It can decide to share synthetic data. So Cancer Registry of Norway, one of the research they are doing is to develop models for synthetic data. So by using those models, they do not share the real data. They can share only synthetically generated data based on those models. But of course, the models would approximate the real data. So this is one tool that Cancer Registry of Norway possesses in order to balance this trade-off between privacy and ability to share data. So what you see here is the simplified diagram for the access life cycle, because again, like there are several things which are not presented here. So first, it all starts, like the proposal phase is actually also broken into two stages. The first stage is statistical inquiry. So first, the data processor, like the institution that wants to develop, say, new medicine, needs to submit some statistical information. How much data it would require, for how long. So just an overview. So first, this overview is being reviewed, and there is a loop, like a loop here. The data controller may decide to approve it, but may decide to ask for refinement, and then it goes back to the start. If it passes the first stage, meaning the statistical inquiry is approved, then it allows the data processor to submit the full-fledged project proposal. So with a lot of details added. So a project proposal needs to specify like really about answer 50 different questions. So including which legal base, for what kind of data, and for each kind of data for how long. These are just would it be okay to send synthetic data for this purpose? So all this information are considered at the stage of the project proposal. And then the proposal also undergoes an approval. And finally, if it doesn't pass, then it goes back for revision. It also checks the feasibility, because maybe the request is say to share huge amount of information for a very short period of time. Well, that would not be totally feasible, right? So there is a question of privacy, but there is also a question of feasibility, and all of those need to be considered. But if approved at the end, it would go to the health data request, and here the data processor would request healthcare data based on the approved project. So of course, each such request needs to be verified against the previously submitted proposal, and sometimes the minor adjustments can be allowed, but again, that would be a lengthy process. Then there is a question, for given a request for data, there is a need to consider whether this piece of data would require consent from the user or not. Not all data requires consent from the user. If it does, then the consent management system kicks in. So consent management takes into account all of this, but especially starting from phase number 3. And if consent requirements are satisfied, the data is sent, but again, there are many details and many different flavors of sending the data to ensure security in the transfer or in sharing. And then separately of this, there is a policy update. So what does it mean? It means that a patient may decide to share a particular piece of data at a given moment of time, but later the patient is allowed, if I remember correctly, like 3 times a year to change the previous decision. And as soon as previous decision is changed, this needs to be taken into account, and there is a cool-off period, like several days, during which it's still possible to use the data, after which the data processor would need to return the data and also prove that it doesn't have the access to the data any longer. So there is a need, okay, so it's incomplete because it doesn't show, for example, how reports are generated for the purpose of giving the reports to the patient. And the reports also need to be given to the supervising authorities, like the last rule in GDPR. So what the project did, I mean, one of the targets and one of the goals that was achieved in the project was to provide a consent management scheme which monitored all the cycle and all the steps. You can see here and some additional steps, and would be verifying that making sure that all the steps are performed in a secure way, and also in compliance with the regulations and in compliance with consent given by the patient. So there are many requirements to consent management platform. So lack of reliance on a trusted third party is always a good thing. So this is why one of the reasons why we use blockchain here. Of course, use of security cryptographic primitive provides additional guarantees with regard to integrity of the project description. Also, very important, the non-repudiable interactions between involved entities, so that later the entity would not be able to deny something the entity did in the previous phase. And verifiability. So sometimes the requests are denied, and in this case, both data processor and the auditing authority needs to verify the reasons for denying the request. And similarly, there is a need to verify involvement in projects. So I'm not going to present the technical solution, but the solution, so again, it's based on a published paper in the project. In this paper, basically, a platform was described, and the platform provides a number of guarantees. It uses consortium blockchain without the need for a trusted third party. The data is difficult to tamper with, in particular project description and all access-related information. Non-repudiation, so all interactions are performed via smart contract calls and signed by the corresponding entity and stored. Therefore, it would be possible to verify that the interactions indeed happened at a later stage. And finally, it provides transparency and verifiability for all the entities involved in the project. both when the request is denied and also when the request is approved. So this is the end of the lecture. I would like to thank you. Hello, welcome to the third lecture today. So we are considering next use case of blockchain penetration into infrastructures at the level of e-governance. And this use case is about the taxation system and the recording of taxes. So taxes usually is a very complicated topic. So in Norway, we used to say that the person needs to take a PhD in how taxes are calculated in order to understand, to get initial understanding of the system. So it looks like in India, the taxation system is also quite elaborate. So it's so important because gross domestic product or GDP of any country is highly dependent on the tax paid by the citizens of that country. And the tax payments are obviously compulsory and need to be enforced. There are many various entities in the taxation system, public and private sectors. Where the rules may be somewhat different. Individuals, wholesalers, retailers, tax authorities, banks, and so on. So taxes, so here's just an example of some of the taxes, or rather, it's more or less a complete list of the types of taxes, not the exact taxation rules. So there are direct taxes on the income tax, and there are indirect taxes, for example, on the sale tax and service tax, and custom and VATs and goods and services tax, which we are going to consider in greater detail later. So what role can blockchain play in the taxation system? It can be used for storing and validation verification of invoices, can be used for verification of payments, automation, for example, automatic calculation of reminders, fines if there is any delay with payment of taxes, and so on. Of course, tamper-proven and security of records, verification and validation of the tax forms, cross-border transaction monitoring, and of course, if built successfully, such a system would contribute to building of trust. And of course, it eliminates some human bureaucracy and thereby may bring reduced compliance cost. So here in this illustration, you see an example of a VAT system built on blockchain. So in this particular system was built on top of Ethereum. It's also using the IPFS storage, which is a blockchain-assisted storage. I'm going to cover it tomorrow in my last lecture. And the system, of course, in the system there is VAT administrator, there is seller, buyer, and the bank. Those are the main entities that interact and store information on blockchain. So here are some examples of successful uses of blockchain in the tax system. So like spread over different countries. In Brazil, there are actually two interesting use cases in Brazil. The first use case is the Federal Tax Administration of Brazil implemented a system based on blockchain. So it's called BCPF. And the point of the system is to share data from a register of taxpayers between tax and regulatory institutions of the three levels of government, including federal, state, and municipal. So it's mostly for sharing the data and verifiability. The second system developed in Brazil is for custom tax. So Mercosur Customs in Brazil is connected by BConnect, blockchain network, for the purpose of Federal Tax Service of Brazil, and connects customs in Brazil and nearby countries of Argentina, Paraguay, and Uruguay. So the purpose of the system is to guarantee the authenticity and security of custom data shared between the Mercosur countries, the 4 countries, and it allows the exchange of information from economic operators. Another example is from European Union. In the European Union, there's been a proposal to create a digital invoice register, which would allow tax authorities across Europe to view and verify the taxes paid when a product changes hands. A few additional examples. Argentina, which was also part of Mercosur, it implemented a single tax registry, federal register, which is abbreviated as RAT, a tax simplification mechanism that allows taxpayers to comply through the same channel with the formal requirements of tax registration, declaration, and so on. A few additional examples from Europe. In Finland, the tax authorities started working with banks on a blockchain system to track taxes on real estate transactions. In Sweden, blockchain is being tested to digitalize receipts and non-resident income tax and custom duties. Probably the 2 most advanced countries in Europe in terms of the blockchain penetration and regulations are Estonia and Netherlands. Estonia has moved a number of government services to a blockchain system, including banking, health, and business records. So a significant part of the national Estonian infrastructure is based on blockchain. Netherlands is one of the countries that has been promoting blockchain-related legislation in Europe. They've had many success stories. One of them is that they're the startup working on a blockchain-based accounting system that tax administrator could use to combat fraud when it comes to the VAT tax. But now let's come back to the Indian context and specifically consider the GST tax, which is one of the many taxes in the Indian taxation system. So GST is abbreviation for Goods and Services Tax. It's an indirect tax which replaces former taxes in India, such as excise duty, VAT, services tax, and so on. It went in effect, so the GST Act was passed in the Parliament in 2017 and came into effect later same year. So it's a relatively new act and a relatively new taxation system. The tax is being levied on the supply of goods and services. It's comprehensive multi-stage destination-based tax that applies to every value addition. So you can see the illustration here from the Clear Tax website. So clear doesn't mean that it's all clear, it's just the signature of the organization that produced the illustration. So for example, when buying raw material, manufacturer buys a raw material, VAT applies. When manufacturer sales the end product to wholesaler or to warehouses, VAT and excise duty would apply. And from the wholesaler to or warehouse to retailer, VAT would apply. And finally, the consumer would also need to pay VAT, and always covered by GST. So the tax is levied at every point of sale, as you could saw in the previous diagram. And what's interesting is that it applies differently in the case of interstate sales and interstate sales. So in the case of interstate sales, there are 2 components, central GST and state GST. And in the case of interstate sales, are chargeable, the tax is chargeable to the integrated GST. So integrated GST goes to the central government. So in this case, the taxation, in the case of interstate sales, the taxation would be a bit different. So here's an illustration. Suppose a dealer in Gujarat has sold the goods to a dealer in Punjab, and the goods are worth, say, 50,000 rupees. So, and in this case, the tax rate for interstate tax is quite high. It's 18%, comprising of only integrated GST. So in this case, the dealer has to charge 9,000 rupees as IGST. And this revenue will go to the central government. Now, a different scenario would be if the same dealer sells good to a consumer in the same state, Gujarat, which would be worth 50,000. And then the GST rate on goods is 12%. And this rate comprises central GST at 6% and state GST at 6%. In this case, the dealer has to collect 6,000 as goods and service tax, of which 3,000 go to the central government and 3,000 will go to the Gujarat government. So this is an example of a calculation, and of course, all this needs to be automated. So here comes a blockchain network, again, developed in the Indian context. It's called GST chain. It's a conceptualized, designed and developed, again, by the same Center of Excellence in Blockchain Technology, National Informatics Center, to record and store the tax-related documents in secure manner using blockchain. So what's the purpose of blockchain? GST details, so it stores details such as tax payment, demand, liabilities, invoices, notice, bank payments. All this is stored on chain, or at least secured by the use of chain in a hybrid storage. The documents in the off-chain database would include tax payment and the invoice, but say the hashes of the documents stored in the off-chain database would be stored on chain for the purpose of extra security. And there are many entities that participate in this system. Again, the government, suppliers, recipient, GST officers, monitoring the blockchain data, and the financial institutions themselves. So this brief presentation of the use case was prepared using a number of references from the very same Center of Excellence in Blockchain Technology, and but also from a number of papers, such as Navigating Blockchain Technology Integration in Tax Policy, Navigating Challenges and Unlocking Opportunities for Improving the Taxation of Ghana Digital Technology, and Automated Tax Return Verification with Blockchain Technology. That concludes the lecture. Thanks for your attention.